Hormesis-inducing agents, such as sulforaphane and quercetin, exemplify a fascinating and paradoxical principle in cellular biology that certain types of mild, transient stress can actually strengthen the body's defenses and improve long-term cellular resilience. This phenomenon, known as hormesis, plays a central role in how living organisms adapt to environmental challenges. At the molecular level, these compounds trigger adaptive stress response pathways that lead to increased antioxidant production, enhanced DNA repair, and more efficient cellular maintenance, all of which contribute to the preservation of telomere length and the slowing of biological aging. Sulforaphane, a sulfur-rich compound found in cruciferous vegetables like broccoli sprouts, kale, and Brussels sprouts, is one of the most well-studied hormetic phytochemicals. When ingested, sulforaphane activates the NRF2, nuclear factor erythroid 2, related factor 2, pathway, a master regulator of the body's antioxidant and detoxification systems. NRF2 activation leads to the upregulation of a wide array of cytoprotective genes, including those involved in neutralizing reactive oxygen species, detoxifying carcinogens, and repairing damaged DNA. Since oxidative stress is one of the most potent drivers of telomere shortening, the induction of this endogenous antioxidant response plays a key role in shielding telomeric DNA from degradation. By strengthening the cell's natural defenses without overwhelming it, sulforaphane initiates a hormetic cascade that helps delay the onset of cellular senescence and supports overall genomic stability. Quercetin, a flavonoid abundant in apples, onions, berries, and leafy greens, works through a similarly elegant mechanism. It also induces mild oxidative stress that prompts a cellular adaptation, including the enhancement of mitochondrial function and the upregulation of antioxidant enzymes. Quercetin has been shown in cell and animal studies to stimulate pathways involved in DNA repair and inflammation control, such as AMPK activation and inhibition of the NF-B pathway. These changes improve cellular stress resilience, reduce chronic inflammation, and protect against the DNA-damaging effects of oxidative molecules. Though telomere lengthening per se is not typically observed, the rate of telomere shortening is slowed, which over time may translate to meaningful gains in cellular longevity and functional health. The most exciting aspect of hormesis-inducing agents is their ability to mimic the beneficial stress responses typically activated by physical exercise, fasting, or caloric restriction, without requiring dramatic lifestyle interventions. In this sense, they may function as nutritional stress mimetics, helping the body maintain a youthful cellular environment even in the face of aging or external stressors. This makes them especially appealing in modern contexts where environmental toxins, sedentary habits, and processed diets can rapidly overwhelm cellular defenses. Rather than simply providing passive antioxidant support, sulforaphane, quercetin, and similar compounds help train the cell to become more self-sufficient and resilient, activating protective mechanisms from within. What's more, these agents are generally safe when consumed as part of a whole food, plant-rich diet. Sulforaphane is highly bioavailable when obtained from raw or lightly steamed cruciferous vegetables, especially broccoli sprouts, which are among the richest natural sources. Quercetin, though less bioavailable in its raw form, can be made more effective when consumed with healthy fats or in supplement formulations designed for improved absorption. Unlike pharmacological interventions, these compounds do not overwhelm the system but rather nudge it toward a healthier, more adaptive state. Recent research is also beginning to explore the synergistic effects of combining hormetic phytochemicals with other longevity-enhancing strategies. For instance, activating the NRF2 pathway through sulforaphane may complement the DNA repair and telomerase supportive effects of sirtuin activators like resveratrol, or amplify the anti-inflammatory benefits of a Mediterranean diet. Such combinations could lead to more comprehensive protection of cellular structures, including telomeres, over the long term. Though more human trials are needed to quantify the exact effects of hormesis-inducing agents on telomere dynamics, their indirect benefits are increasingly clear. By enhancing antioxidant defenses, improving mitochondrial performance, and reducing systemic inflammation, they create a cellular environment that favors slower telomere attrition and greater genomic integrity. These compounds may not extend telomeres directly, but they appear to slow the processes that cause telomeres to fray and shorten prematurely, a subtle but critical distinction in the science of aging. In the broader narrative of longevity and health span extension, hormetic phytochemicals serve as a reminder that stress, when delivered in small and controlled doses, can be deeply beneficial. Compounds like sulforaphane and quercetin don't merely shield cells from damage, they help cells learn how to protect themselves more effectively. In doing so, they support one of the most fundamental goals of aging well, preserving the integrity and vitality of our cells down to the level of our DNA.